Welcome to the SONAR Slinky activity. Did you know that most new cars use sonar or sound wave sensors to detect nearby objects? Just as some animals like bats, whales, and dolphins use sound waves for echolocation, most new cars use 8 sonar-type sensors in their bumpers, 4 in the front and 4 in the back, that constantly emit sound waves to detect nearby objects. But how come you can't hear any sound coming from the bumpers? And how do these sensors use sound waves to detect objects? Well, in this lesson, you're going to use a Slinky to help answer some of these questions and learn more about how sound waves travel. So let's take a look at some of the materials. Each group member needs to have their own student activity sheet and a pair of safety goggles. Each group needs a Slinky, at least 2 meter sticks, stopwatch, a little bit of masking tape, and some sort of tablet, or phone that has the video function on it so you can record your Slinky. So let's take a look at our setup and our group roles. So there's 3 members to a group, so I snagged a couple of volunteers. I have Watson, who's a mechanical engineer in the crash avoidance team, and we have Jacob, who's a digital outreach coordinator in the social media team here at the Institute. Our job as the Slinky holders is to hold it firmly and to take turns sending pulses and waves down the Slinky, not to do it at the same time because the waves will interfere. Jacob's job is to use the stopwatch, the meter sticks, and the tablet to measure and record data on the wave's motion. A few safety tips. Keep the Slinky flat on the floor, hold it firmly, and don't release it. All of us should be wearing our safety glasses when the Slinky's stretched. And for Jacob, when he's doing the filming of the Slinky, only film the Slinky, nothing else. In part 1 of your lab, after you've measured the full length of the stretched Slinky, you need to create a sound pulse, also known as a longitudinal or compression pulse. Here's how you do it. You quickly push and pull the Slinky forward and back, which compresses the coils and sends the pulse down the Slinky. Send one pulse, let the Slinky die down, and then try another one. Also try varying how hard you push to see how that affects the size of the pulse. When it comes to making the wave, you're going to send multiple pulses down the Slinky to create the wave, like this. Try varying how quickly you actually make those pulses, because in this lab, you need to figure out how the wavelength is related to the wave's frequency. So to do that, first thing you need to do is measure the wavelength. First, place 2 or 3 meter sticks alongside the Slinky. Then, as one person is creating a wave, one of your partners records 5 to 10 seconds of video. Once you have the video, you can play it and pause it to measure the distance between 2 pulses by zooming in on the Slinky and the meter sticks. The distance between the 2 pulses is the wavelength. Remember the safety tips. Keep your safety glasses on. Hold your Slinky firmly when you're making the waves. Don't let go because it can get permanently tangled. So good luck and have fun.